All right, guys, today we're going to talk about transformations, and this will apply to all of the functions that we have been talking about. Okay, so if you have a vertical shift, that is a shift up or down in your graph. So you can see that in a couple of ways. So here, g of x is being changed to fx here to plus 5. So that's going to be up 5. And this would be down 2. Horizontal shift is left or right. And for every function, every single function, the horizontal shift always comes out opposite. Okay, so here you'll see it says x plus 3. So that's actually going to be left 3 because it's a positive 3, so it comes out opposite. And then x minus 5 will be right 5. Okay, so you have to think of that as opposite. And see how this is connected with the x? That tells me it's going left or right because x moves left and right. Okay, then you have a vertical stretch or a shrink. If your a is greater than 1, the a has a vertical stretch, has occurred, causing your points to closer together. Okay, so like for a parabola, it would get really tall and skinny. Okay, if it is a fraction or less than 1, it is a shrink has occurred. Okay, sometimes that is also called a compress and causing your points to pull away. Okay, when it compresses, it gets short and fat. Okay, so here, this is a stretch by 2, and then this is a shrink or compress, according to what you've seen in the past, by 1/3, okay, because it's less than 1. All right, if a is negative, this will cause a reflection across the x-axis. Okay, so a negative here in the front is the x-axis. Sometimes you will see one where it has like this, and that is a reflection over the y-axis. Okay, so here's an example of E. The red is not reflected and the blue is reflected over the x-axis. All right, just a reminder, these are the functions that you need to know. The quadratic function, the cubic, exponential, square root, cube function, linear, absolute value. A couple that's not on here is cubic and logarithm. So those are just some more. I like you to see those parent functions. It shows you with the vertical stretches and stuff. So A can tell us if it is reflecting. And then according to whether it's greater than 1 or less than 1, whether it is stretched or shrink. Okay, and then H moves left or right. And then K is up or down. All right, so those are things that you should know about transformation. So let's do an example here. If we're looking here at this graph, okay, first of all, this is a quadratic, you know, because it's being squared. Okay, the original function is y equals x squared. Okay, that means at 0, 0, 1, 1, negative 1, 1, 2, 4, 1, 2, 4, negative 2, 4. Okay, so this blue is our parent function. Okay, so if we take the parent function and we do the transformation here, so x here, x minus 2, means that we went right 2. Okay, and then plus 4 means up 4. So I can take this first point, the 0, 0, I go right 1, 2, up 1, 2, 3, 4. So that's going to be our new translated point. Then I take this point here and I go over 1, 2, up 1, 2, 3, 4. I can take this point here and go over 1, 2, up 1, 2, 3, 4. I can take this point here and move it 1, 2, and then up 1, 2, 3, 4. Take this point here, move it 1, 2, and up 1, 2, 3, 4. And so this is the transformation when we move right 2 and up 4. So it's just like we picked up that blue and moved over 2 and up 4. Now, if you're having trouble with this, you can always take this and put it in your graphing calculator. So you're going to hit y equals, and you're going to do parentheses, x minus 2 squared plus 4. And then you're going to go to your table, and you're going to see that 0 is going to be 8. And you're going to use that table now to graph. So we can use that table now to check our points. I'm trying to get it to come over. Okay, so we have the point 0, 8. That was in our table. Then we had the point 1, 1, 2, 3, 1, 2, 3, 4, 5. Okay, and then we had the point 2, 4. So we can use the table to also do that. Okay, but I just wanted to show you how to translate it. Okay, so let's look here. Okay, this negative in the front tells me it's been reflected. And then this means it's going to go right 3 and then down 1. Okay, again, if we think about our original function, 0, 0, 1, 1, 2, 1, 2, 3, 4, 2, 1, 2, 3, 4. So this would be our original function. Okay, if it is reflected, that means that this point here would be reflected right there. Do you see how those are reflected? Then I need to move that point right 3, 1, 2, 3, and down 1. Okay, so that would be my point that I would use there. That would be that new point reflected. If I take this one and I reflect it, and then I move it right 1, 2, 3, and then I go down 1, that new point would be there. Okay, then I can take this one and reflect it. So it's 1, 2, 3, 4 above. So to reflect it would be 1, 2, 3, 4 below. And then I'm going to move it right 1, 2, 3, and then down 1. Okay, now the point 0, 0 can't be reflected, but I can move it 1, 2, 3, and down 1. Okay, I know that this point here will also be over there. So that would be my new transform graph. All right, let's look at one more of these and then we'll just talk about the reflections and stuff. All right, here it's moved left 1, because remember it comes out opposite, and then up 4. The original function is y equals the square root of x. So the original function we'll continue to do in blue, 0, 0, 1, 1, 4, 2, 9, 3. So this would be the original function graphed. Okay, so if we take each point and we go up left 1 and up 4. Okay, so left 1, up 1, 2, 3, 4. That 0, 0 is now at negative 1, 4. And then this point here, we go left 1, up 1, 2, 3, 4. This point here, left 1, up 1, 2, 3, 4. Point here, left 1, up 1, 2, 3, 4. Okay. So now the translated function is going left 1 and up 4. All right, so let's look at just what's happening here. Okay, so this is being reflected. It is right 1 and up 5. All right, guys, let's turn the page and look at this. So here, they've just given you, instead of graphing and everything, they're just giving you function notation. Okay, and then you're going to talk about how it's translated up, down, left, right, vertical factor, stretch, or horizontal, vertical factor, or horizontal, and then reflection. So let's look at this first one here. So you'll notice this is not with the X, the 3, the plus 3 here. So that is our K. So that's going to be up 3. Same here, up 5. Now notice here though, it's with the X. And what did we say earlier? When it's with the X, it always comes out opposite. So instead of going left 4, it's going to go right 4. Okay, let's look down here. This is with the X. So that's going to be right 1, up 2. Okay, so this here is up or down. Okay, this one would be left 2 and down 1. All right, so let's look here at the reflection. Notice this is on the outside of the function, so that will be over the x-axis. This one, though, is on the inside, so that's going to be the y-axis. All right, if you notice here, we have negative, which is a reflection over the x-axis. And then it is being stretched because that A is greater than 1. You only look at the number, you don't look at the sign. The negative tells me it's reflected, so it's going to be stretched by 2. Okay? All right, so you'll notice that there. And then this one here is stretched vertically by 2, so you may put vertically here. And then down here, when we have 1/3 x, okay, if we have that 1/3 x there, that is going to be compressed. And then it's going to be horizontally by 1/3. When it's on the outside, it's the vertical. On the inside, it's horizontal. All right, so I'm going to let you try a few of those and see how you do. And that is transformations. Please check Plan Book for your assignments.